And then I've got a really simple project, and there's a little bit of code, and I'm going to demo it for you. Are any of you guys software developers or product people?
In a previous slide.
Okay.
Yeah.
Okay, no worries. And it's not meant to be like an example of like, okay, this is how you definitely build this. It's just to kind of give you an idea of like, hey, it's not that complex. You don't need to be a math PhD to apply these things for your teams. So if you're, integrate with teams or you work with teams that build product, you can, tell them, hey, I've seen an example and it's not as difficult. So don't be afraid. Go for it. Okay, a little bit about myself. I'm just going to talk briefly. My name is Mike Lee. I'm the co-founder of GovAI, and we build a sales assistant that works on difficult tasks for salespeople or repetitive tasks that are boring. And today we just exited our private beta, so we're now open to the wide world.
Nice.
So so we've got a handful of customers, and we're excited to kind of get some more. So I'm just hoping to share a little bit of what I've learned because, at my time at this startup, I've built AI agents and productized them for our customers. So I hope I can just kind of share some of what I've learned. All right, so I'm sure most of you have used generative AI probably today already. And if you haven't, you probably use it pretty much daily. It's either ChatGPT, Claude, or a tool like Perplexity. These are really powerful tools, and it's been amazing to see how in the past couple of years, AI has had its like iPhone moment. I think AI has been a buzzword for the past 10 years, but really in the past couple of years, it's really had massive adoption. So one of the most important things about this talk is to just talk about how the differences between ChatGPT or technologies like it and AI agents. So the first thing that you need to know is tools like ChatGPT, they are general purpose tools, and they're really powerful. I like to describe them as the Excel spreadsheet of AI. And you can use Excel for a lot of different things. You can use it to plan your vacation. You could use it to manage your software development team. You could use it for your financial planning. And because it's so powerful and it's capable of so many things, you can take on a lot of different use cases. But eventually, people built purpose-built applications to take on those use cases and challenges. So in the same way, many experts believe that the next practical evolution of generative AI is the emergence of AI agents. And they're kind of that same thing of purpose-built. And there's a lot of hype around AI. There's some news articles that have just come out in the past few months. AI agents, they could do real work in the real world, and that might not be a good thing. AI agents are going to roam the internet and replace workers. Forbes is talking about how the inevitability of our dependence on AI agents in investing. So a lot of people are talking about them as the next big thing. And I'm kind of going to break down some of the hype and just kind of give you a practical understanding of what they are. So I'm going to start by just answering the question at a high level, what are AI agents? And I would kind of answer it with two pieces. So one, they're an extension of the large language models. So these are like the base models like GPT-4, Llama, Mixtral. So you're taking those models and you're making them more powerful. But they are not general intelligence. And what I mean by that is like AGI. They're not like a human level intelligence yet. They're somewhere in between both of these levels of intelligence. So let me break down, I guess, with a little bit more detail about what are the components or the main factors of AI agents. So the first thing about agents that you need to understand is that they're autonomous or semi-autonomous pieces of software that can generally act independently to accomplish a unit of work without continuous human oversight or management. So unlike, applications today like ChatGPT, if you go and you talk to it and you say, hey, I want to ask this question, or can you summarize this call, or maybe create some points for a slide deck. When you walk away and you leave your computer, it doesn't keep working on things. It doesn't, act independently on its own time to go accomplish a task. So agents are autonomous. You can kind of set them up and they'll just keep working, maybe not totally autonomously, but semi-autonomously to try and accomplish their goal. So the next thing about agents that's really distinct from general purpose tools is that they're task or objective focused. So they are designed to accomplish a specific task or objective. So there are some agents or agent platforms out there like AutoGPT, and they're kind of limited now. But an agent would be, a piece of software that is purpose-built to accomplish something like maybe build a social media following. So maybe you want to be an influencer or build a presence online. You could have an agent maybe create content and post online for you. Or it could be managing your stock portfolio and, reading the 10Ks and the 10Qs and the SEC documents and analyzing which one to sell or buy. So they're task and objective oriented. So the next thing about agents is that they have to interact with an external environment. Now, this might not seem obvious to you at first. And for this talk, we're talking about GPT or LLM-based AI agents. And these are agents that leverage large language models to accomplish their task. Now, large language models are really, really powerful in handling language and text creation, but they actually have some significant limitations. And I'm going to kind of explain some of them now. They are really powerful, but believe it or not, they do have, limitations to them. So one of the limitations, and I'm sure, a lot of you are aware of this, is that they're limited by their training data. So large language models, they're trained on a huge amount of data that's probably scraped from the web. And you could ask a question that it's been trained on, and it'll probably be able to give you a really accurate response. But they're not trained, constantly all the time. So there's information that's come out that they don't have access to. So if you ask the question, who won this week in the NFL, and you ask GPT 3.5, it's not going to be able to answer accurately. I mean, it might get it right if it guesses, but it doesn't actually know that information because, it was trained a while ago, and, the world has changed since then. And unless it's been retrained with that information, it doesn't have access to it. And this is where you can kind of get some hallucinations, because a lot of times the language models will just take a guess, or they'll kind of, BS their way through the question. Mm-hmm. So that's one of the challenges, is that it's not trained on the data. It doesn't even have access to it. But the other thing that I think a lot of people aren't aware of is that the language model doesn't actually understand the term "this week." So this might sound a little confusing, but these are kind of just like black boxes where you push text into it and they respond. They don't actually know what the current time and date is. So to be able to solve this problem, you actually have to go query the information. You got to get the, who won the game. You got to get that data. You have to add it to the context of the prompt. But in addition to that, you also have to tell it what the current day and time is that it finds itself in. So you have to add context to the prompt for the language model. So the other limitation for these models is the token limit. And for a lot of people, they hear token limit, they kind of understand at an abstract level what it is. What is a token, really? I think all you need to understand at a high level is tokens are basically just words and characters. So there's a limitation on how many words and characters you can send it. And there's a limitation on how much it will actually respond back with. So if you ask GPT model, hey, can you write me an essay, but I want it to have 10 million paragraphs or something like that, it'll start writing, and eventually it's just going to have a hard stop because there's a technical limitation on its capability to output text. And in the same way, if you took 10 million books or, character, words, and you throw it at the model, eventually it just won't even output anything because there are limitations on it. So here are some of the most popular models out there from OpenAI, and you can kind of see the differences in their token limits. So there's one, GPT-4 Turbo. It's got 128,000 tokens. But even though that's, an insane amount of tokens, most of those tokens are only used for adding context to the prompt. It can only write 4,000 tokens. So even though it says like we got 128K, it can only write like 4,000 tokens. So there's depending upon what you're trying to accomplish, you won't be able to get it to write the next Harry Potter books. Okay, so I think, the important thing to take away is that, language models are really, really powerful by themselves, but they still have limitations. And when you're developing an agent, you have to be aware that, hey, there are these limitations that exist for these language models, and you got to implement workarounds to accomplish your task. All right, so I'm going to talk about kind of the architecture that you see with pretty much most large language model agents. And these are kind of just the different pieces that I would say pretty much every agent will have. There are some people who will build agents that can do a little bit more or will have different implementations, but these are kind of the main pieces. Let me go into each one of them for you. So the first thing that I would say an agent needs is what I call external resource adapters. And what this is basically just the APIs that your agent will have access to accomplish its task. So these are kind of the hooks to the outside world that give your agent the ability to learn information that maybe it wasn't originally trained on. So you need this because, like I said before, they're only trained up to a certain amount of time, and your agent needs the ability to go out to the outside world, gather information, and help it accomplish its task. This could be things like current world news. It could be purchasing patterns on a stock or an ETF. It could be just something like a blog post, but it's gathering the information that's in the outside world that it wasn't necessarily trained on. But in addition to that, it's not just gathering information. External resource adapters kind of giving the agent the ability to take action on its environment as well. So these could be things like sending emails or notifying people on Slack, publishing pieces of content on social media. So external resource adapters, they're giving your agent the ability to access information that it wasn't trained on, gather information, and also take action on its environment. Because if all it is just gathering information, you're just kind of building a database. You want it to go out and accomplish something. All right. So the next thing that you'll likely do is something that I just call a long-term memory system. Some people will call this RAG. Some people will call this data stores. But I think in just the most basic terms, it's a long-term memory system because when you go to a language model, you ask it some questions, you leave, and you come back again and you create a new prompt context. It forgot everything that you talked about before. And there are different solutions that people have to try and persist the memory, but you need something to give it long-term memory. So the two main pieces that are most important about this system is you need to be able to store all the relevant information that your agent might need to accomplish its task. And you need to be able to access it and retrieve that information only when necessary. Now, you need this because you can't take all the information you have and just jam it in the context of your prompt because there's a token limit, so it can only take so much. And also, the more that you add, depending upon what your use case is, it can lead to hallucinations and you're just adding noise that can confuse it. Or it might still work, but it doesn't work as well as it could if you gave it just the most precise amount of information. So a long-term memory system needs to retrieve all its information, but only when it's necessary so that you don't include a bunch of noise in the process. Okay, now one of the most common tools to accomplish this for your long-term memory system is a vector database. Now, I'm not going to go into like super technical detail, but I guess I just want to cover this and just so that you kind of understand some of the terminology, because a lot of people are going to throw this term around. And you might ask yourself, okay, what is a vector database and how is it different than a normal database like Oracle? So a normal database, kind of like Oracle, is really good at structured data. And vector databases are really good at storing and retrieving unstructured data like text. So why would you need this? Why can't I just use a Postgres or an Oracle database for my memory system? And in some cases, you absolutely can. But because you're working with language models and they deal in text and responding in text or generating text, a lot of times you need to search for your relevant information by text. And when you have an Oracle database, if you're trying to search by text, it can be, it's hard to not just search by word, matching on text. You're trying to understand like the context and kind of the intent of the text. So vector databases are just a great way of accomplishing that. How they work. So it starts by basically converting your text or your strings into vectors. And vectors are just like a list of numbers. If you think about a very simple vector would be like a plot on a graph, like an X and Y coordinate. And that's all it really is. It kind of just is taking a bunch of numbers and putting it on a graph. Now, with simple graphs, it's just like two coordinates, but with AI and text embeddings, it's like thousands of numbers. So it's like a multi-dimensional graph, and all you have to know is like it's a big list of numbers. So you take an article, like you could take an article or an internal document from your company, push it through a text embedding, and it just says, all right, I'm going to create a bunch of numbers that represent it. And then you can take those numbers, put them on a graph, and then you can search for articles or other pieces of content that are similar to it. So an example of this could be, like I have a vector database here. This is just kind of like a crude example where I have a bunch of tweets or tweets that I've made and I've stored them in my database. And they have a vector or like a coordinates on a graph that represent them. And then I could ask a question to my agent and I say, hey, I want some past tweets that I've made about AI. And it could take that text and push it through an embedding. And then it'll create a bunch of numbers that kind of represent my question. And then look on the graph and kind of say, okay, what are the numbers that map closest to that? And it's never going to be like a 100% match. But it kind of just lets you see how close you are to it. So it's just a great way of searching kind of by text. Yeah.
Sorry. How does it know that whatever tweets is like -0.2?
Okay, so that's a great question. Basically, the way that text embeddings work is that there are models built that
already
exist,
okay.
Kind of like with the association of these words and where they live on.
So it's built using that, and then it's retrieved using the same model, almost like encryption key. Okay.
Yeah, and not every company, but like OpenAI, they have a particular embedding that does the conversion.
Okay.
And Google probably has their own that does this conversion. And if you tried to use one to search for the other, it wouldn't work. It wouldn't work at all.
So what do you all use? You have your own?
I use OpenAI's.
Okay.
Okay. But I'm open to anything. So, but
yeah, to throw something.
So anyways, it's just a way of kind of searching with kind of mushy information because, a lot of times if you use a database, and you're like, I want to search by this user ID, their ID is number 1. All right, find the row that's number 1. But if you're trying to search by a question, past tweets about AI, it's pretty hard to do with an Oracle database in the same way.
But when it comes to like OpenAI vector database, when you do document chunking, so then you query it. Let's say there are two documents which are relatively having the same amount of information and then the same amount of key. How would OpenAI prioritize over one key over the other?
Oh, so they don't actually store the information. They just have the vectors, and I store it in this for myself.
Yeah. So even if you store in the vector, there should be some key which is pointing to relevant right?
Yes. Yeah.
Which one? How to prefer over keys if they are pointing to same amount of information or same pattern of information?
Yeah, so it depends on kind of like the use case that you're trying to solve. But a lot of times, so I work in sales, we'll add additional metadata to these rows. So we'll add additional metadata like, hey, this is for kind of content that you can send to a prospect, or this is an internal document, you're not supposed to share this with prospects. So generally I'll add additional metadata to kind of give the context of what that information is. Because, you know, you could have something that's consumer facing or prospect facing that's very, very close to something that maybe only your company should be viewing. So you kind of have to add additional metadata to it. Now, if you don't have anything that distinguishes it, a lot of times you kind of just have to pick one. You kind of just have to make a decision and generally just pick one. Yeah, okay. So I'd say the other piece for, main piece for agents is dynamic prompt creation. So your AI agent has gone out, it's gathered information that it wasn't originally trained on. And then it has an intent or a task that it's trying to accomplish. And it has to kind of work all these things together to create a prompt that creates a deterministic output. So many people just call this prompt engineering. That's kind of a term that's thrown around a lot. Prompt engineering, dynamic prompt creation. But this is basically the process of combining all of the information that the agent has access to with the goal it's trying to accomplish and sending something to the language model that gives you the correct output. All right, and then I'd say like kind of the final piece for your agent is just a nice user experience for the human to interact with. And depending upon what your agent actually does, this could look totally different. So there are some agents that all they are just, a Slack bot or a Slack channel. And there are some companies that build AI agents and they have no user experience other than you just add a Slack bot to your Slack, and then in the background, their server is running agents on your behalf, and you interface through Slack. And then it could just be an email. Like there are some companies that they have agents that are hooked up to a mailbox, and you can just say email them and ask them questions, and they respond, or you can send them documents and like, hey, remember this, and it'll add that to their memory. But whatever it is, this is just the experience where the human interfaces with the agent. Before I move through kind of like a real world example, I just want to leave you with some things to consider as you guys kind of apply this stuff. And one of them is like kind of picking out which model should you use. So should you use an open source model or a private model? And you can have pros and cons with both, but with an open model like Llama, you generally can run it a lot cheaper. There's a little bit more transparency in how it's built. And then you can have community support that'll kind of give you some valuable insights in how to accomplish certain things. But with the private models from like OpenAI or Google, generally you have a higher quality of output. Other questions that you should think about for your team is, should you self-host a model and run it on your own infrastructure, or should you run through a service, an API service? And if you self-host it, depending upon the scale, it can save you a lot of money. But if you're a smaller scale, it'll probably cost you more. And if you have a service like OpenAI or Google running your model, you're probably going to have a little bit more reliability, depending upon how great your team is. But it reduces the responsibility of your team to maintain the infrastructure yourself. The other thing that a lot of people will ask is, should I fine-tune a model? Like, should I train it myself or fine-tune it? And I would say, a lot of the times, depending upon what your use case is, fine-tuning, generally, I wouldn't say it's worth it that much, because one, there are new models coming out that perform really well, and then the cost goes down. So the effort you put into fine-tuning it might not be, you might not see the return. But I would say if you're doing something where you have a high volume, high frequency, high volume, and it's kind of a well-defined space, especially if it's kind of like classifying, customer support, stuff like that. You're trying to classify incoming information. Fine-tuning could definitely be worth it, but you need a lot of data to actually train it accurately. The other things to consider, I'm sure you guys have heard about this so much, is just being safe with the data. Data safety is really important. You might be handling people's personal information. You could be handling trade secrets, and you just want to be careful that you're not training your models if you fine tune, that you don't train it with, personal information. And then you want to be aware of who actually has access to your data. So a lot of people here work in, the government space or government contracting. There's probably a lot of people here who have, security clearances, and you want to be really careful that the projects you're working on, even in development, if you're interfacing with, a service or a vendor, you have to be cautious about the vendor, who they are, and also, know for sure if they're storing the data, because a lot of vendors will just store the information to train other models or to just improve the quality of their current models. So if you send a bunch of people's, hey, this is this person's social security number and, other information, even though it's never exposed to a human, it might be stored somewhere that you don't want it to be. So you should just be very cautious about what data you're sending around. I like to remember this slide from last year when a Samsung employee accidentally leaked a bunch of their trade secrets to ChatGPT. And then it ended in Samsung banning ChatGPT for all their employees because a guy's just taking some code, which is like some proprietary stuff, and asking questions, putting it into ChatGPT. And they actually use that information to train other models. And so then if you ask the next model that's trained, sometimes that information is leaked out. So, a lot of people here work in the DoD space, so, be cautious about what you're doing.
So if you upload data
Yeah.
to a ChatGPT query to help you answer a question,
Yeah.
that's now public information.
No, I wouldn't say so necessarily. So it depends, because they have certain products where you upload files. And I believe, I'm not sure, but I think they've publicly stated that that kind of is isolated to your instance, your
Sure.
user.
Yeah, this is a case if you've got a contract with ChatGPT for doing some kind of function.
Yeah.
If you're using it, let's say personally on the open,
Yes.
and you upload a file data with data in it, that now is public information.
I don't know if uploading a file would be, but if you're uploading text, like if you're chatting with it, I would say there's a good chance that that text is stored to train future models. So it may or may not be used. I wouldn't say it's necessarily just publicly exposed, but when you're interfacing with it, and even if you take a document, you upload it in there, it may or may not be used in the next model.
Okay, so let's be gross here. By accident, we upload someone's social security number.
Yeah.
Would it be fair to say that a way to test this is in the next iteration to ask, what is this person? So, and it'll give it to you if it knows it?
You could ask that. I suspect that OpenAI will probably have a lot
Some
of
kind of a-
mechanics. Yeah, but I think that, they're a really reputable company running a bunch of stuff, but there's a lot of people that run other services offering AI solutions.
Okay.
And I would be cautious about who you're interfacing with, because there's going to be a lot of people that probably will do that. But I can't speak for OpenAI directly.
Okay, sure.
But for Samsung, and this was a while ago, they got dinged. So yeah. All right. I'm just going to quickly walk through building an agent. I'm going to fly through this because I don't think most of us are software developers. So I'm just going to kind of quickly roll through here just to kind of give you a picture of kind of the simplicity, and that, if you interface with teams and, you got a product guy, which is like, oh, it's too difficult to build, or it's going to take forever. You can tell them, no, I saw a guy with a man bun in Reston, and he showed me that it's not that difficult. Okay, so just for an example, what are we going to build? I'm going to build a LinkedIn ghostwriting agent. And so this is going to go and write LinkedIn posts on my behalf, or articles that I can post. Just is going to find relevant information on the web that's interesting to me, but it's got to kind of reflect who I am and past opinions that I've made, because it's pretty easy to just go and say, hey, write an article, but I kind of want it to reflect who I am by, information I've exposed in the past. Some of the things that I'm going to use Brave's news API, and they're kind of just like their search engine, similar to Google, but they have an API where you can just gather information, news and articles. And then I'm going to use a vector database to store past tweets I've made and personal opinions. And then I'm gonna have just a really simple UI to glue it all together. So I built a web server using Go. And then I used a database called PG Vector, and this is just an open source vector database, and it's just built on top of other SQL databases. So it's very, very simple to use. And then let's see, yeah, I have an example here of just creating an embedding, and it's really, really simple. You can just take some content, and this is just some text. I put it into this function that, you know, is in SDK. And it just creates a long list of numbers that you can store in your vector database. Yeah, I use a Brave Search API, and I just create a just an interface to gather data from their API. And then kind of like the way this works is the agent will go out and find an article, you know, something that's interesting to me, GPT to AGI, and then I'll take old tweets that I've made in the past and then combine them together and create like a new piece of content or, you know, a LinkedIn post. Yeah, if you're interested in the code, I'm happy to share it with you. You know, just hit me up on LinkedIn. Yeah, let me give you a really quick demo of it. And let's see. Oh man, I gotta go on this screen here. All right, so here is what it looks like. It's a very crude and simple project. But here I go into the settings and I configure stuff that I'm interested in. So green technology and AI. So you kind of tell the AI, hey, I'm interested in these topics. I want you to find me a couple articles a week to write and do this every week. And if you just set it up like this, it's going to autonomously go and just write me articles that I can post on LinkedIn. But I also want it to kind of reflect who I am a little bit. So I've kind of made some gross examples here, but I've uploaded a bunch of tweets and opinions that I've made in the past. And so these are things like, hey, the intersection of AI and government policy is, you know, crucial. AI advances ethical considerations, you know. So I've just uploaded a bunch of tweets just to kind of reflect who I am as a person. You know, these are not my actual tweets. I'm not that corporate-y, you know. All right. So basically the way that this thing is going to work is you're going to use both the information that it's been trained on with its long-term memory and kind of go and access information that it wasn't originally trained on, you know, because these articles, I've kind of got it set up to be somewhat recent articles. So the language model wasn't trained on these. So it's supposed to go out and find information that's related to green energy, green technology, and AI, and then kind of use my past tweets, just write something new that I could post on LinkedIn. Just gonna let this thing run. I hope it's working. So yeah, here's one. So it's taking an article from Bloomberg and it's kind of just writing a new thing, a new article or a new post that I could make. And in bold, I've kind of heavily instructed the AI to emphasize past opinions that I've had, just for an example. So one of the tweets I had is basically this paraphrase: technology is amazing when people are responsibly using it for the good of mankind. So it's kind of taking your values, cramming it into a new piece of content and making a post about it. So, you know, this is just a really simple example that you could have.
So Michael, do you actually use this, do this?
No, I'm not actually posting these on LinkedIn. I'm not a big LinkedIn.
Oh, you're
user.
not.
I'm not really a big LinkedIn person, but we do have, I know of people who do this, and that there are just whole projects that are set up to actually just write the content.
So the next thing becomes, okay, so how effective is the post? So like an SEO. How
Yeah,
about that? Do you write an agent that says, you know, we need some quality control. I need, you know, 5,000 people to read it.
yeah.
So then,
Yeah, can you just make it happen? So you can do things to have your agent optimized for things like SEO, but it can't just magically make it perform at that level. And I'd love it if it could, but one of our customers, you know, we deal with salespeople and we write emails and we write subject lines. We want people to click on it And he said, man, we're getting, really improved click-through rates. But I want them to take demos. I want them to take meetings. Like, can you get the AI to make them do that? And I said, it can only do so much. It only has so much capability.
No, but I
So-
mean, marketing is what marketing is, and
Yeah.
it's about whatever it is that you're doing that results in people clicking through or buying the
Yeah.
product or what have you. And you can measure that. So I said, you know what? It's really great to see you today. How many responses do I get on really great to see you as opposed to, good seeing you?
Yeah,
I mean, it is that nuanced, and we can measure, well, how many people bought because I said, great seeing you, as opposed to, I really like, I mean, I'm
yeah, I know
up
what you
here.
mean. Yeah, you can definitely use AI
That's
to
the way it's done.
measure like things that are harder to measure. I think I understand your question a little bit more. Is you can use AI to measure things that are harder to quantify with traditional computing. So if you went to an article and you say, hey, what are the main key elements of this article that performed better than the last one? You could quantify those and get them into either a taxonomy or some sort of scoring system, and then say, hey, we want more like that. You could do that. Now what I just demoed doesn't have that capability in, but you could implement another degree of capability for your agent to be not just taking information, creating a new one, but then measuring its own performance. And you'd have to go and get that data, bring it into the context, measure it, and then kind of you'd have to build that into kind of the loop that it exists in. But yeah. Does that answer your question?
Yeah.
Okay, thank you. All right, so I just want to end with kind of just some summary is that agents are autonomous. They're task and objective based so that they're not just general purpose. And they interact with the external environment to either gain information they weren't trained on or to take action. And then the main elements of agents are they have to have external resource adapters, so connect with the outside world, either gathering or taking action. They have to have a long-term memory system. They're dynamically prompting themselves to create an accurate output from the language model. And then you got to have some sort of user interface for the human to connect with it. And it could be as simple as a Slack bot or as complex as a whole web application. Thank you guys for being here. My name is Michael Yee, and hopefully you enjoyed this talk. But I want to I just wanted to give you guys maybe a little confidence or kind of demystifying kind of the buzzwords of agents, and so that you guys can kind of take AI agents and, if necessary, or if you want to, bring them into your organizations or teams to create value. So yeah, thanks.